Pythagoras' theorem. This is working through the C I can, so the C grade skills for Pythagoras' theorem. Use Pythagoras' theorem to calculate the unknown sides of each triangle to the nearest whole number. Obviously we start with our formula, c squared equals a squared plus b squared. We substitute in the known values. It's often a good idea to label your sides. Hypotenuse is c, the other two are a and b. It doesn't matter which is which, but the hypotenuse is c. Substitute in your values. X squared equals 4 squared plus 7 squared. Because our x squared is on the right, we know we don't have to rearrange, so we're adding 4 squared plus 7 squared is 65. X squared is 65. We've got our answer for x squared, but we need our answer for x. So we square root 65. Second function, square root 65. Checking if you can read that on my calculator. There we go. Enter. Now if it only gives you a square root answer, that means you've got to push the double arrow key and we'll get a decimal, 8.06. Now because we asked for the nearest whole number, x equals, the nearest whole number is 8. The units in the questions were meters. We could have put that answer down here if we preferred. X equals 8 meters. And in fact I'd accept not giving this line if you didn't want to. Another finding aside, write the formula, c squared equals a squared plus b squared. Label your sides, c for the hypotenuse because it's opposite for the right, to the right angle. A and b, doesn't matter which is which. I usually find it's easier to make the unknown side if it's a short one a, but it does not matter. Substitute your values in. 21 squared is x squared plus 18 squared. Because my unknown is in the middle, that says I'm going to need to rearrange and it will become subtraction. Hypotenuse squared minus the shorter side squared. Find our answer for x squared. 21 squared minus 18 squared. Oops. 117. So x squared is 117. That's our x squared answer. We need our x answer, the square root of 117. Excuse me. If we get a funny answer, again, we want a decimal, double arrow key, 10.81. That would mean our nearest whole number was 11. The units were centimeters, so that side is 11 centimeters. So that's finding a shorter side. For these sets of 3 numbers, decide, showing working, whether it would form a right-angled triangle. That is it a Pythagorean triad or triple? So these questions can come in 2 forms. Sometimes they'll give you a triangle, 5, and ask you if it's right-angled. Sometimes they'll just give you the 3 sides and say, if I made a triangle with those 3 sides, would it be a right-angled triangle? It's the same sort of question. We solve it the same way. There's a couple of different ways of doing the working. I'll do one each. One is to write the formula, substitute the values. Longest one must be C, and evaluate each side. 26 squared is 676. 23 squared plus 5 squared. 554. They do not equal each other. So we can change that to say does not equal, and because the 2 sides don't equal, c squared does not equal a squared plus b squared, so it is not a right-angled triangle. The other way you can do it is work out c squared and a squared plus b squared separately. Longest side, excuse me, so I've got c squared, then I work out a squared and plus b squared. 6.25. And because they worked out the same, c squared does equal a squared plus b squared, therefore yes, that would make a right-angled triangle. And we need to use Pythagoras' theorem to solve word problems. A 9-metre ladder is leaned up against a wall. The foot of the ladder is 4 metres from the wall. How high up the wall does the ladder reach? So how high up the wall is what we want to know. We do assume that the ground and the wall make a right angle. If you're ever stuck, you can always redraw just the triangle, but you don't have to if the triangle is already there. And then it's just solving. We write the formula. We substitute in the values. We discover that we need to rearrange. Get our answer for x squared. 9 squared minus 4 squared is 65. Square root to get x on its own. Arrow key to get a decimal answer. 8.06 meters. And because it's a word question, if we were being very careful, we would give a word answer. How high up the wall does the ladder reach? The ladder reaches 8.06 meters up the wall. A gate is 3 meters wide and 2 meters high. A diagonal crossbar needs to be added for stability. Find the length of the crossbar. Because there's no diagram, you have to draw one. It's a rectangular gate, 3 meters wide, 2 meters high, and we're putting in a diagonal crossbar, and we need to find the length of the crossbar. Write your formula. Substitute your values. Because x squared is on this side, we don't need to rearrange. 9 plus 4 is 13. We've got our answer for x squared. X is the square root of 13. Notice how I have everything written down as to what I'll do before I grab my calculator. It makes it easier to not make silly mistakes. And that would be a 3.6 meter crossbar, and again you would give a word answer.